right?
Mhm.
But what I mentioned before is that there could be just a solution to equation 1, and that would be like B. There could be just a solution to equation 2, which would be a C, and there could even be a point that's just neither, to be on the lookout for. And that's really the challenge of these questions here. So let me snip in the entire question now. So the entire question states, let me get this framed in the screen a little better. It says, which of the following is true about 12 comma minus 8? And you just found, though, that the solution is 5 minus 3. So again, if you go back to our picture, that's that point. We actually don't know where 12 minus 8 is. It could be on one of the lines or the other or here. And the only way to know is to test that point in each equation. Okay, so will you do that for me and tell me whether it's an A, B, or a C, or line equation 1, equation 2, or neither?
Okay. Is it a solution to neither equation?
Yeah, so I don't believe it actually works in either one, because 5 times 12 is 60. That's 48. So when you subtract them, you don't get 7. Minus 60. Wait. Wait a second here. Maybe I did that wrong. So minus 5 times 12 minus 7 times minus 8. Does that equal -4? So that's -60. 7 times 8 is positive 56. So it does work in that second one.
Oh, okay. I used what did I do? Oh, I wrote positive 6y instead of negative 7y.
Okay. Yeah, it's so it does work. So it is, so that, and so that's where these, I mean, this, you will never see anything this difficult, but this is where the answer space is even like another layer. But it's the problem is designed to show you all the possibilities. So
Mhm.
it's not a solution to the second equation. That's not true. So no, because it does work. Is it a solution to the first equation? No. It's not. So this is where it's really confusing, because it's not a solution to the first equation, which is true.
Okay.
So the point here is that you have to be able to solve systems, and then furthermore, you have to be able to get try the solutions in there, and then lastly would be getting the right answer. Now, if I can get you to solve the system quickly, if I can get you to figure out whether the point's on one or both, then I think we're in really good shape here. So
Okay.
let's try another one here. Another one here. Okay, so we'll do the same thing here. I'll have you solve the system. I know we're spending a lot of time on systems, but the the things you do on systems like adding equations, subtracting equations, substituting back in, these are skills you're going to use in other problems. So, okay, take a look at this here. Notice this time you can't just add them, because when you add them, they're both the same sign,
Mhm.
positive, positive, negative, negative. So you can either subtract, which I know isn't all that comfortable to do, or you can multiply one or the other by -1 and then add. Okay. Do you need a refresher on that, or do you feel comfortable just subtracting or doing this to solve for one of the variables?
Trying to think. I think what's the hardest way to do this is the subtraction one for
Yeah.
me.
Yeah. So let's multiply the first equation by -1, and then
Okay.
right below, we're going to write the result below it, -5x plus 2y equals +1.
Okay, and then do you subtract from there, right?
You add
Oh,
them up, add them.
okay.
So it's 7x minus 5x, that's 2x. The y's cancel, equals
3.
6. Yeah, so x equals 3. And then you always want to go back to the original equation. So choose either equation, but I'd like you to solve for y for me, please.
Y equals 8.
Okay, so y equals 8. I'll just check that in the second equation. 7 times 3 is 21, minus 16 is 5. Very good. Okay, so again, there's only one solution. Okay, unless and there's a situation where they're the same line, but there's only one solution. So when we snip in the rest of the problem here, I'll do this kind of in steps here, just so you can get familiar with this. And by the way, this is a strategy, testing strategies, to just do piecemeal it here, like do that part and then do that part before you look at the answers. So this right here is not the solution. We can agree to that. This is not the solution, because that is the solution. 3/8 is the solution. That is not the solution. Okay.
Okay.
So what is it? And that's where it's, not ideal because a lot to do here. So 5 times 15, -15 is -75. 2 times -2 times -37 is +74. So that works. Okay. Now again, this is kind of interesting, because I think, and this is where this is kind of an advanced thing, but you're totally capable of doing this, since it works in the first equation. Okay, and let's call this equation 1. Since it works in the first equation, we automatically know that it is not on the second equation. So you don't have to test it. Like, and I know you want to put that into this second equation, and you want to say, okay, it didn't work, but it's like, if the light's on in the room, the switch is on, it's not off. If the fridge is open, then the door is open, and you don't have to go to the next equation. You can just say, okay, it works, does not. Okay. And then you can get the full, the full thing here. You can say, all right, well, which is it? Which is the right answer? Because I know, because you could say to yourself, I know the answer. I just got to match it up with the one that's there.
Mhm.
So it looks like it's that one.
Yeah.
And thank goodness, right? Like we didn't have to do much more than that. Okay, let's try another one here. And then we'll move on to a new topic potentially. So we mentioned that there are other techniques for elimination. And when you can't just add the equations, we can't just multiply 1 by -1. Sometimes you have to multiply one equation or both equations by a number. So you can choose to multiply either the first equation by 4, because that will give you -8x, or you can multiply by 2 because that'll give you -6y. It's your choice, but I'd like you to try solving this system.
Okay.
Julia, how are you doing on this one?
I got the value of x, which is 3, and then when I plugged it into the original equation to find y, I think I did something wrong.
Okay, tell me, did you multiply the first equation by, you must have multiplied it by 2 because you solved for
Yeah.
x. So that's minus 4x minus 6y equals 8. Add them up. So that's 4x equals 16. Divide by 4. I get x equals 4. I think you said 3 there. Maybe you didn't multiply this 4 by 2.
Oh, yeah. Okay.
And that's a common thing. You got to multiply all three things, or in the case of a negative, you got to make sure you distribute it to everything. So keep that in mind. Okay, so now that you have x, why don't you try solving for y? It should you should reasonably be able to get a value there. Let me know when you come up with a value for that.
Y is
Say that one more time. Y is negative.
negative. I got -4.
-4. Okay, let me check here. So let's put it back into that second equation. 8 times 4 plus 6y equals 8. So that's 32. Yes, y is -4. Very good. So plus 6y equals 8. Okay, so that's the solution. Okay, and again, the question, the way these questions are written is they give you a point. That point could be on one of the lines, but not the other. So this point is not the intersection, but it could be on equation 1 or equation 2. So I'd like you to take this point and put it in for equation 1 and then put it in for equation 2 and see which one it works. Works in one, works in the other, doesn't work in either.
Okay. I don't think it works for either of them.
Okay. All right. Well, actually, let me check the answers key to make sure that is the case. I think it is. Yeah, it is. Okay, very good. All right. So we have a choice here. We can do some more systems stuff, like not just not solving them, but questions related to systems, meaning like other uses of linear equations, or we can go to a completely different topic. Do you have a preference, or
Can we go to a new topic, please?
Absolutely. Yeah. Okay, so let me find And I'm going to stick with, yeah, here we go. Okay. I'm going to stick with heart of algebra. We're having a little more success with these. So let me just throw the problem at you, and then we'll see how much background we need to cover before doing some of these types of things. So, okay, it says they're giving you an equation: 1 over 4k plus 1 over 2k minus 1 over 3k equals a. It says if k equals negative 4/5, they're giving you that value of k. They want the value of 1 over a here. So what would you do first? And there's really two paths here, I think. Do you what kind of stands out to you to do first?
Maybe plug in negative 4/5.
Yes. Okay. So let's do that, and I'll show you how that looks. And sometimes these things get worse before they get better. Okay. So in the denominator here, you multiply the tops. Okay. So it's 1 over negative 16 over 5 plus 1 over negative 8 over 5. And then this negative could go with this negative, which I would probably do at some point. It becomes 12 over 5. Okay. And then this is a question for you. What do you do when you have a fraction in the denominator? Do you recall how to simplify that?
I don't really remember.
So the shortcut off to the side here is like, let's say it's 1 over a over b. This becomes b divided by a. And the reason it does, and I'll show you here in this first one, if you multiply by the reciprocal on the top and the bottom, on the top, you get 5 over negative 16 because anything times 1 is itself. But on the bottom, the reciprocals cancel and you get 1.
Okay.
And so that's why this shortcut over here on the right is so powerful, because, and you will see stuff like this where it's 1 over a fraction. You will see 2 fractions over each other, which we'll talk about in a bit. But this is all about reciprocals. It's all about understanding that 1 over 1/2 is really 2. Because, and it's a speed thing. It's like, okay, you don't have a calculator, but you got to be able to manipulate that. So the result here is that you get negative 5 over 8. Negative 5 over 8. So you can actually put that negative sign wherever you want. And then 5 over 12. Okay, so it's really, just write this slightly differently. It's really negative 5 over 16. So you really got 3 fractions. Okay. You know how to add fractions, right? You grab a calculator, but what if you don't have one? How do you combine fractions?
You make sure all of them have the least common.
Yeah, you got to make a common denominator. And this one is not ideal. I believe 48 is the one that works there. So in the first one, you would multiply the top and bottom by 3. That's negative 15. Second one, you multiply the top and bottom by 6. And then the top and bottom by 4. Okay. And so you've got negative 45 plus 20. So negative 25 over 48 equals a. But if you go back to the original question, did it want the value of a or did it want something different?
It wanted 1 over a.
1 over a. So if you want 1 over a, how does this fraction change on the left?
Does it flip?
Yes. And it flips because the same reason we flipped it earlier, 1 over anything becomes the reciprocal. Okay, so let's go back and look at this problem again. Okay, I'm gonna show you another way to do it, but this is the so the first step was to substitute in a number. That's not difficult. You can do that. The next step was to simplify a fraction or multiply a fraction and then simplify, which you can do. And then you can find a common denominator, okay, which you can do. And then you had to remember to flip it at the end. So there is no single step here that you can't do. It is just a matter of realizing that you just have to work through it. So there is kind of a shortcut here. I'm going to grab the question again. So what I just showed you is what I would consider the direct method. It's kind of the way you would see it in school method. The alternative method here is to combine these fractions before substituting in that number, because you would agree, I think, you could tell me you don't, but I think you would agree that like making a common denominator there was some work there. You had to know, 48, you could have picked a different number, but between 4K, 2K, and 3K, those are a little bit smaller. You can actually do it over 12K.
Oh, okay.
Okay. So how do I do that? Well, you multiply the top and bottom by 3, top and bottom by 6, top and bottom by, and you can leave the minus there. So it's by 4. Okay. So this is 9 minus 4. So that's 5 over 12K. And the answer then, and this is where if you're clever, because you've looked at and tried some of the approaches we've done, since it really wants 1 over a, you realize, oh, it's 12K times 5. And now how many times do you have to substitute the value of K into the problem? One time. But you only have to do it one time. Do you see that?
Oh, okay, yeah.
Rather than, and so the summary is you get the same answer. You get 12 times minus 4/5 over 5. You get negative 48 over 5 over 5. So this 5, so the other one is if you have an A over a B over a C, it becomes an A over B times C. Basically, this number on the bottom comes up here, and you get negative 48 over 25. So you summary, you get the same answer, the exact same answer, but there's a shortcut, and the shortcut is not the one that's obvious, because you did nothing wrong with that. You put the number in, simplify the and take the reciprocal. You have a choice. Like you can do either one. Okay. It doesn't matter to me which way you go, but I would recommend trying to combine the fractions first before doing that. So let me give you a problem here to do. Excuse me. Let me just grab some questions here. Yeah, here we go. All right. Let me try and grab one that's similar to one we just did. See if I can find one of those real quick. Yeah, I guess we'll try this one. Okay. All right, so give this one a try. And I'll check back with you in a moment. How are you doing on this one?
I got 45 is my answer.
For 1 over A or A?
For 1 over A.
Okay. Fantastic. That actually looks like it's correct. Let me check the answer key. Ooh. It actually is one. You found that A is 45, didn't you? So 1 over A
Oh,
would be
okay.
1 over 45. And I didn't put up the answer key because it's this one's all the wrongs are there that you would normally do. You can see here that like that. Okay, so that's great. I'm actually really impressed you're able to do that in the first go around. So let's just do a little bit of reviewing reciprocal fractions. Okay, and so the first type one, we'll call it, we've just done, it's 1 over A over B. Okay, and this always flips. So an example is 1 over -3/5 becomes 5 over -3. And then that negative can actually go in any position. It could be -5/3 or it can be out in front, whichever way you like. right? So the next type that you might see is let's say there's a number up top, number A over B. It's really the generalized type one, because you flip it, it's n times B over A, right? And so an example here is you might have something like 4 over 16 thirds. So this is 4 times 3 over 16. And now you have a choice. And this is not taught in schools. This is a standardized prep thing. You divide before you multiply, because order of operations, multiplication, you see M before D, so you think, okay, I'm going to multiply, but you really want to divide because the numbers get smaller. If you don't, you're going to have bigger numbers to deal with, which is usually a more complicated one. Now they don't always simplify. It could be 3 over 10 ninths. Let's put a negative in there. So this would be 3 times negative 9 over 10. Those don't divide, and you get negative 27 over 10. The next type that you might see is, this would be type 3, is something like this. You would have A over B over C over B, and this equals A over C. And so an example of this would be like, let's see here, 5/12 over 9/12. This is 5 over 9. So you just take those top numbers.
Okay.
And then the generalized one is type 4. It's the generalized one of the previous one. It's A over B over C over D. And this becomes AD over BC. This is the one you're going to see most often in some capacity. Like somehow a problem will turn into 5 over negative 9 divided by 3 over negative 10. And that becomes, and sometimes like, oh, it looks like it's going to work out nicely. Well, we'll see. 5 times negative 10 over negative 9 times 3. So you get negative 50 over negative 27, 50 over 27. And so you should be able to quickly do these without a calculator is the idea. So let me give you a couple examples here to try. So let's look at the first one here. 5/9 over 9/8. Could you try simplifying that for me, please? Do you have an answer for me on this one?
So far I have 5/8 over 9.
Okay, this is like the last one that we did, where you just reciprocal that bottom number. So see how this bottom number goes with the top number, this C goes with the B. So it's 5 times 8 over 9 times 9. This one comes up here, and then this one comes there, and that's 40 over 81.
Oh, okay.
Let's try one more here. Let's go -3/5 over 9 over -7. So you should get -3 times -7 over 5 times 9, 21 over 45.
Yes, that's what I got.
Fantastic. All right, well, that does take us to the end of our lesson for today. I know we've got another one scheduled here in about an hour for probably, I guess we're going to do some physics.
Yes.
So I will see you then.
Okay, thank you.
Bye.